Welcome to AI for Good, the leading, action-oriented, global and inclusive United Nations platform on AI. Organized by the International Telecommunication Union, the United Nations Agency for Digital Technologies, in partnership with 50+ UN sister organizations and co-convened with Switzerland. The goal of AI for Good is to unlock AI's potential to serve humanity. In today's AI for Good event, we are counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished facilitators and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Hello, and welcome all to today's workshop on real-time 3D urban CO₂ and district heating visualization with GeoAI, QGIS, and Open Data. My name is Andrea Manara from the ITU, the International Telecommunication Union, and it's a real pleasure for me to introduce a new episode in the GeoAI Discovery Series. We launched this series beginning of 2022, and we have been organizing over 40 episodes so far. Webinars, hands-on workshops. The current focus of the series now is on geospatial large language models and also the organization of hands-on workshops like this, which are focused on building up practical skills in applying AI to geospatial data under the leadership of the curator of this series, Professor Maria Brovelli. I'm really pleased to introduce this workshop as while we mainly focus on Earth observation data in the GeoAI Discovery Series, today we would be dealing with practical application of GeoAI, where the relevant geospatial data are cadastral data, CityGML building models for smart cities. In this regard, I would like to inform the audience of related activities in the ITU Standardization Sector Study Group 20, which is responsible for development of innovative standards, guidelines, reports, methodology, and best practices for the Internet of Things, digital twins, and smart sustainable cities and communities, with the goal of accelerating digital transformation. I'd like to mention also the United for Smart Sustainable Cities Initiative, a global UN collaboration coordinated by ITU, UNEP, and UNECE, which serves as an international platform for exchanging knowledge and fostering partnership to empower cities and communities in achieving the UN Sustainable Development Goals. If you missed some episodes of the GeoAI Discovery Series, don't worry, you can watch the recordings of those events on YouTube or on the neural network to which you are connected right now. Without further ado now, let me introduce Maria Brovelli, who will moderate today's event. Welcome, Maria. Maria is professor.
Hello, Andrea.
Maria is the professor of GIS at the Politecnico di Milano at the Geoinformatics Engineering course of study and member of the Schools of Doctoral Studies in Data Science and Earth Observation at Roma La Sapienza. Amongst her many activities, Maria is Vice President of the Commission of Geospatial Information of ISPRS, Vice President of the International Society for Digital Earth, a member of the board of the UN Global Geospatial Information Management Academic Network. Welcome, Maria. The floor is yours.
Thank you, Andrea. And yeah, so exciting that today we are starting the new series of GeoAI for Good. And as Andrea said, we want on one side to focus on geospatial foundation models, or something that it's in this frame of large language models for geospatial information. On the other side, we want to focus on applications where GeoAI is used for managing data with the GIS tools that many people already have known, like for instance QGIS. And so today, what we want to present is a 3D web application for the real-time visualization of CO₂ emissions and district heating demand, powered by GeoAI and Open Geospatial data. The system you will see is a system integrating ALKIS cadastral data. We will see what they are, CityGML building models, and infrastructure layers within QGIS and PostgreSQL, and display them interactively using CesiumJS. So you see a lot of open source software put together, integrated together with this system. Then a custom GeoAI model estimates the CO₂ emissions and heating demands at the building level based on attributes such as usage type, construction year, geometry, rough structure. So updates made in QGIS or remotely via QFieldCloud, another open source important tool, are instantly reflected in the 3D environment where buildings are dynamically styled according to emission levels or district heating connectivity. This system is a scalable open source framework which supports climate responsive planning, suitable for energy infrastructure design and also for decisions making at the municipal level. Now is the time of introducing the speakers. So I will call here Hamid Reza Ostad Abbas and Mohammed Hossein Golizadeh. So welcome the two of you, and thank you for accepting of teaching your system in this workshop. So let us introduce you quickly. Hamid Reza is the head of the Geoinformatics department at DS Tag Stadtentwicklung GmbH in Stuttgart. Sorry for the pronunciation is not good, but I don't know. I'm not able to speak in German, so you will say better later. Hamid Reza has over 8 years of experience in GIS software development and geospatial consulting. He's also a lecturer at the Stuttgart University of Applied Science, where he teaches courses on AI, smart data, GIS applications, and he teaches to the master's students. In addition, Hamid Reza is the CEO of GIS World Tech, a Stuttgart-based startup, and he serves also as a young representative of the Council of the European Geodetic Surveyors. So congratulations, Hamid Reza. And before giving you the word, I want also to introduce Mohammed. So Mohammed is a full-stack GIS developer with over 3 years of professional experience at the Steg Stadtentwicklung GmbH. He specializes in building geospatial applications, and he has a strong expertise in 3D development, web-based GIS, and GeoAI solutions. He's also a certified Cesium developer and is passionate about creating innovative GIS and GeoAI applications that bring advanced 3D visualization and analytics into real-world projects. Fantastic. So thank you for being here. And I will leave you the word now. I know that Hamid Reza, you will start. And in the beginning, you will present the system, and then we will go toward the practical part. Okay, thank you, Hamid Reza. And now the floor is yours.
Thank you very much, Maria. I hope you can see my screen right now.
We can. It's not in presentation mode, so you have to put in presentation mode.
Okay, let me just... How about now?
In my opinion, you have to select what is written. I don't understand, but it's Anzeigenstellungen and select duplicate presentation, because if not, we see the current slide and also the next one.
How about now?
Now it's fine. Try to change it
Okay.
to go to the second one in
Okay.
order to be super sure. Yes, fantastic. You
Okay,
can go
great.
back. Okay,
Great.
thank you.
So thank you very much, Maria and Andrea, for the nice introduction. And I think all participants got known about a topic that we would like to talk today. And I don't want to repeat our topic again. And your pronunciation, Maria, was correct at the second time, and it was a great improvement, I can say. So let's, as you said already, I will start with the first like 10 minutes or even less or a little maybe more with the introduction about our application. What is the application? Why we create this application? And after that, showing some kind of a finished product, and you have also this chance to check by yourself. The application is free of charge. You can check it by yourself. And also, when we are done, we will jump to the praxis mode and we will check it together, the platform. So let's start. Yeah, here is the introduction, or maybe the most important part for the challenges. And because, recently cities are increasingly focused on improving energy efficiency and reducing CO₂ emission in urban redevelopment area. And as you know, energy assessment, require complex data and different tool to compare condition before and after renovation, because this renovation topic is very important, especially in Germany, because we are not creating the new building, we are just trying to renovate those buildings. And how to get the first estimation of CO₂ reduction and energy demand with just only minimum number of the input and without knowing high level technical knowledge. Since for the creating or to have this CO₂ reduction, we need a lot of parameters and knowledge, but with this app, we are trying to reduce and how to use it with the minimum number of the input. And another important challenge is that how to clearly show and communicate the result with the non-expert users. It's a private experience somehow, or in this way, because this communication with the people doesn't have enough experience with the GIS software, with the AI, or some technical point of view, how to connect with them, how to share, or how user friendly is the app, is a very important challenge also for us. And another important aspect is that how to use the open geospatial data effectively, handling updated data, new geometry, and expired data sets. Because even in Germany, the cadastral data will be updated every 1 year or up to 2 years, and the data will be changed, the new geometry will be added, or some geometry will be divided into 2 sections, and the system must be intelligent enough to track those changes. So a unified intelligent system is needed to connect open cadastral data, building information, and real-time visualization for integrated energy planning and public awareness. So what is the solution? Maybe some of those screenshots is familiar for you. So we need a set of the GeoAI powered APIs which integrates open geospatial data, ALKIS and CityGML. I will explain to you next slide. And APIs can be connected to the WebGIS, QGIS, ArcGIS, or any GIS software. As you see in the second image, we have the QGIS platform with the one plugin in it, and automatically calculate energy demand and CO₂ emission with the minimum number of input, allowing fast and reliable assessments in this way. And this is the important part, provide real-time 2D and 3D visualization and dynamic CO₂ reduction chart for clear interpretation for entire community. In the first or upper screenshot, you can see we have the map and the chart and some information which came to the pop-ups, and enables auto-generation of district heating layout through simple polygon selection, supporting data-driven and sustainable urban development. In the last image, you can see we have the 3D model, and by just creating one polygon, we can have the district heating, and we will explain you short. This is an important question to all of us, or maybe many users from coming not from the Germany. What is the ALKIS data or base of this system? So before going to that, what is the open geo data? Geospatial information that is freely available for everyone to use, share, and update. And this is our main focus. No extra cost is needed or licenses. And our main data sources is ALKIS data, official German cadastral data, and this data is based on the XML format, and we have over 600 layers in it, which contains parcel boundaries, building footprint, and some other information. And for the CityGML 3D city models, we have this like a volume, area, and some other information. And we have the Cesium 3D tiles created from CityGML data to show interactive 3D visualization of building and urban area in real time. Also, we are using the OpenStreetMap to add extra information which is not available in the ALKIS data, this German cadastral data like roads, park, and some other map feature. So you got it, why we are using free, reliable, and regularly updated. So you can see our workflow, how our GeoAI app is working. We have the open source data plus user inputs. How is this user input? We are capturing these inputs with the QField or QFieldCloud, which is the open source software, and it will be added into our database, and which is transferred to our GeoAI app. We can calculate energy demand plus CO₂ emission, and by having the building's geometry and defining specific zones with the polygons into our map, by using our GeoAI app, we have the district heating network plus heat density. Let's explain you more. In this energy demand and CO₂ emission estimation, in our model input, we have some user input like a construction, class, year, heating system type, because we need the information from the owner of these buildings, and how is the renovation status of the building component like a windows or outer walls or roof. And app input is the building footprint, which is coming from the ALKIS data, open data, building volume and area, which is coming from the CityGML, and U values. What is the output from this app is energy demand, specific energy demand, and CO₂ emissions. Why do we need this? What is the usage? CO₂ emission prediction for actual status of the building before renovation scenarios, CO₂ emission estimation after building renovation, and comparative analysis of pre and post renovation emissions to quantify reduction potential. What does it mean? Because by just adding some kind of value to check regarding to the windows, if we change the windows, how is the result? For example, in a year, how many CO₂ emission can be saved or energy in this way? Another part of this our GeoAI app is district heating network. Model input, defined zone of the interest like a polygon, area selection, and default app input is energy demand of building, selected building footprints for pipe network generation. Output optimize pipes routing network, heat density of the main and house connecting pipes. What is the usage? Assessments of the economic feasibility of district heating implementation before and after building renovation. So let's jump to see what we are doing in this app before starting the praxis. Yeah, in this energy app, we would like to show you here first in the first video data foundation, ALKIS, and CityGML integration. So you can see the data here. We have the ALKIS data, integration of the ALKIS data, cadastral parcel, and CityGML 3D building model for almost over 1,000 communities in Baden-Württemberg, which is one state in Germany, and soon we are adding also the Sachsen states. You see, we can just search for the building, for the municipality, and after that we have the data which is connected to our database, and also it will be updated from the municipality. Automated, updated, ensure always current cadastral and 3D information. And centralized APIs architect provides harmonized access to the parcels, building, and Cesium 3D tiles generated from CityGML data and connected to the latest ALKIS data set. And this platform is ready to be connected to any official cadastral data worldwide, supporting global integration through standards geospatial APIs. As you see, this is the Cesium part for the 3D visualization. And the second part, GeoAI for energy demand and CO₂ analysis in this way. From simple input to reliable estimation, without too much or any specific technical knowledge, user can obtain the first estimation of the energy demand and energy consumption before and after renovation. As you see in the video, we have some general information and giving some information regarding before renovation, like a heating system and construction year class of the renovated windows or such information or wall. And the GeoAI model receives building volume and area of the components such as roof, outer walls, windows, directly from the app datasets combined with the energetic parameters provided by users. Because this is exactly the data which is provided from the user, can be the owner of the building or even the municipalities, and the app can gather all into one database. And based on the basic or detailed user's input, the AI model automatically fine-tunes the U values, which is related to the energy parameters. At the end, calculate energy demand and CO₂ emission at the building, district, or municipality level with the minimal user interaction. So it means just you can see the videos giving some information regarding the after renovation, some years, which is all are based on the formulas, official formulas, and the result form has been submitted successfully, and you see the information is added. And somehow this visualization part, dynamic visualization in 2D and 3D. The platform supports real-time visualization in both 2D and 3D environments. You see right now it's in the 3D, and we have, and powered by open source tools such as Cesium JavaScript, Leaflet, and REST APIs. CO₂ emissions and energy demands are displayed with dynamic color styling and interactive legends. You can see the result, and the legends or charts has been added also. And interactive charts and graphs that show calculated and saved CO₂ before and after renovation, scalable from individual building to the entire community. And here at the end, automated district heating planning. With some simple polygons, you can see with the power of our REST APIs, user can instantly generate a first planning model for district heating network. Just you see, simple draw a polygon around the target area. The system automatically identifies the energy demand of the connected buildings and will pass it to the GeoAI. And the GeoAI model automatically generates the main and house connection route paths and suggests the initial and optimized pipes routing network, as you see in the video. And it is the complete model can be visualized in 2D or 3D as a 3D tiles. So we have the possibility in both platform. This is right now in the 3D platform, and you see the legends are previously defined. So why it's matter? This is somehow the last page from my side, and after that we will jump to the real workshop, how we can get into this application. If I would like to summarize it, from data to actionable urban intelligence, enable fast automated energy and CO₂ assessment without manual data preparation. So there is no need to prepare something, because regarding to the APIs or through the APIs, everything is ready. Support renovation, planning, district heating design, and CO₂ reduction strategy from single platform, and reduces complexity and save significant time and cost for municipality planners and consultants, and empower city to move toward climate neutral development through evidence-based decision making, because there is a rule, or somehow the defined rule in Germany, up to 2040, we have the climate neutral or CO₂ emission, zero CO₂ emission in Germany. It seems impossible, but we are trying with those applications to make this rule or wish in real. And if you are interested to check this application by yourself, giving some kind of dummy information, and check it how it will be working by changing those values, you can just scan the app, or I think it will be also share the link with you with the username and password, and you can check by yourself. So it was a part, somehow the beginning part, some kind of, explanation if we are doing this application, what we have at the end. And I would like to transfer the platform to Mohammed to start the real workshop and jumping to the software, data preparation, and the rest. So I hope, Maria, maybe should we consider some question part, or just jumping to the workshop?
No, in my opinion, we can jump directly to the workshop, and then if there are questions, they will be asked all at the end. But by now, I wanted to thank you, because it was very clear, and I believe that is something very useful for many people, what you are presenting here. So thank you by now, and let us see again later. Now we leave the
Yeah.
word to Mohammed for the
Yes, thank
practical
you.
part.
Yes. Thank you.
So thank you so much, Maria. Thank you so much, Hamid. So let's jump into the practical part. So we have already shared. Let me just also share my screen. So I think right now you should see my screen.
Yeah, we do. We can
Yeah.
see your screen.
Okay.
Yes.
Great. So here it's so I have already shared the link of our also check so I cannot see the chats of the Zoom. Okay. So so here it's our GitHub repository. So you have access to all the materials and all the data and all the codes that you wanted to cover in this tutorial. So I have also some very small slides. These are just as a note, but this is not just some presentations. So the first and the most important thing I wanted to talk about these applications is the amount of the data, so the accessibility. The good thing right now, currently in the Germany, we have our open data accessible for all the states of the Germany. And also they have the uniqueness of the quality. So let's first of all, I wanted to show you, and it will be really, really useful for all the students, more specifically master or PhD students who want to design some GeoAI application, because the first and the most important part is a geodata. So it is not that difficult, just you should download geodata, maybe Baden-Württemberg. So as soon as you are searching about any these words, for example, Baden-Württemberg, Sachsen, NRW, so NRW, so you will access to all the geoportals of the Germany. So let's check, for example, the Baden-Württemberg. So it's in the German language, but working with that, it's not that difficult. So let's see. So in Germany, we have the ALKIS data. ALKIS data is the official cadastral data. As I told you, the uniqueness of Germany's data is really good. And so in this case, if you are from any country in Europe or all over the world, if you have such a data, we can easily connect it to this application and make it worldwide. So we have in the Germany, you can access to different type of data, DTM, DSM, ALKIS data, and also the most important part is the LOD2 data. So the CityGML data, it is very sometimes, so I think right now we have it since 2023 as an open data. So access to such a data, it will be really expensive sometimes, but right now currently and hopefully in Germany and in most of the states, we have the open data. So we can use it very good as a basement of our GeoAI applications. So let's maybe we can try one ALKIS data to download one. So the community or the district, so we are naming it as a Gemarkung. So we are working with Bisin, Gemeinde as a data. And also there is a no specific character of the German. So if you are using so English keyboard or any other thing, so you don't have such a problems. So then we need a Gemarkung. Gemarkung means the district, the small part of the community. So then you can see that you can easily access to that part. Then you can easily download that information. Another good part of the Baden-Württemberg, so I don't know if it is a buggy thing or it is, but I really like it and we have already put it in our database system. So to download as a bulk data for the entire Baden-Württemberg. So for example, now this is the Germany, and as soon as you are clicking on it, so you need to one back and you can just download the data. I want to tell you, you don't need to follow me for the downloading data because all the data has already been ready in the GitHub repository. So please don't think about downloading data. Thus, I'm giving you some hints more specifically for the students. And so if they need some data, so you can go and follow such a things. So you can access it via shapefiles or the NAS format. NAS formats in the XML formats I will show you. So what are those things? So as soon as you are doing the download. So also in the console part, so maybe I can do it once more again. So here you can also have the access to the link. So if you are a developer or you are a geoinformatic things, so it's absolutely easy. So you can just, so you know that here it's the Gemeinde name, so the community name, you can put it and you can do one bulk update of the whole Baden-Württemberg and it's ready for your GeoAI app. Okay, so then maybe also we can search for another also maybe states of the Germany. So again, so we have geo data Sachsen. So also we can add ALKIS. Maybe we can. So then you can see that also it's a very good estate and also NRW. They are they have very good data sources and you can use it and download it and use it as a free data and open and free data. If you have already worked with any type, if you wanted to design or make many web application, you know that how difficult is that to get such a huge data set. So just you should have the name of some municipalities, for example, the Grimo and But yeah, Zaxxon, I don't like it a lot because it's the power. We have a lot of limitations, so you cannot download all the data as a bulk like a Baden-Württemberg, but also it's fine, and you can access to the DTM, DSM, and also if you wanted to have a point cloud, so NRW is the best site in Germany to get some open point cloud data. Okay, it's done. And now let's talk about the challenges. So right now, so the first step of designing any geospatial app, you should have a bunch of the geodata. So right now we have it. And then the next step is the quality of the data. So it's from the geoportal. So it means that everything is absolutely fine. So we have a one source. So we can tell that the 80%, 70% of data, it's all the same. But still, we have again some problems. Cleaning of the data and also maintenance of the data. So as Hamid has already mentioned about it, we have a large, big problems of the updating of the data. Data can be changed during a time. So some buildings are demolished. We have some new buildings. We have some renovations. The usage of the building can be changed. So here we need PostgreSQL or a very good data set behind it. Okay, let's maybe I can just open some data here and then we can take a look. So as I have already told you, everything it's in our GitHub repository. So if you are familiar with the Git, I don't want it to go very detailed. So you can just clone it or just very easily just download it as a zip file and just extract it in the folder directory like me. But definitely clone is the perfect. And also at the end, I will define you a little bit a small task if you are interested. So just maybe you can fork this repository and after that you can send it to us. So and anyone who wanted to continue this process, we are more than willing to have this communication with them. Okay, so this is the folder that I have already cloned. So we have a data, we have a PyQGIS and start and final data set. So in the start, this is the part that it is about the web application. But at the beginning, I wanted to just talk about the data, which are the most important part of any GeoAI applications. So in our data set, we have the ALKIS. Again, it is our official cadastral data. So just I will extract it here. And also in the CityGML data, I will do also the extraction. Okay, good. So I will back to ALKIS data. So you don't need to do anything special. So if you have any type of editor, it doesn't matter. So Visual Studio Code, Notepad++, anything else, it doesn't really matter. Just open it there. So I will do it like this. I will open it in the VS Code. Easy. So the most important thing about the data, you should always be sure that your data is the unique and also it has a same structure of the data. So I think you will hear this name Gebäude a lot. Gebäude means building in German. So good. So here you can see this is a set of the data. So why Postgres is important? Because you cannot keep all these XML files always up to date. So you should have somewhere to clean your data and somewhere that you will 100% sure that, yeah, these are my data and these are the clean and they are ready for designing and also for training your AI model. So maybe it is not really understandable. Maybe I can just drag and drop it in the QGIS. I do know that it is not a very good way, but this is the fastest way right now. And if you are any interested in how to open this data or such a things in the, so we have some ALKIS importer exporter, but this is not right now our topic to talk about deeply in it and how, so this is more than enough right now. So here we have different type of layers. These are all these tags that I have already mentioned. So these are the XML files and according to all the XML files, so we have some bunch of the tags plus all these tags, it will make a very uniqueness of the data and all of them are in the OGC standard. So when we are talking about a very good data, everything should be based on the OGC standard. And if they are based on the OGC standard, we are 100% sure our data is clean, so we don't have any fear of any mistake in our training of the model. So just I will double click on the Gebäude building. So the first step, ALKIS data is very complex data set. So you have already saw that it has, so if you are using it with the ALKIS importer exporter, it will be maybe over from 50 to over 400 tables in the database. So you can see that it is good, but maintenance of that is very difficult. When you have a new ALKIS data, so just think about your data set is about entire Baden-Württemberg with over thousands of municipality, the communities. So how you wanted to keep all the data up to date. So then you see also the data is not, you don't know that this is a residential, this is a commercial, this is a school or such a thing, because they are very, the type of the building is important for our applications and or for any type of GeoAI models. So then now it is time to think about the better way. So you should have a place, put all the data there. So now it's time to use PostgreSQL or any type of database, SQL. For me, it doesn't matter. Just somewhere that we can put all of our data set there. So here, just I will show you just what we have already done for our this application. So just zoom to layer. So it is somehow, because of this is a demo app, it is not the complete version of it according to German's data security and so on. So this is, you can see right now, the bunch of the Baden-Württemberg data, it's there. So just think about, we have already downloaded all these small data sets, and then we push all of them in one row to our database. So we have a one table as a building or as a Gebäude. So all the information is there and the data is clean. So let's do some filtering and just take a look at the data to see that which type of data we have there. So then test, so here it's just 13,000 and it doesn't matter which municipality. So good. So as I have already told you, this data it is completely cleaned. So this is not our original data set, but this is enough for our workshop and tutorial. So here the most important part is the type of the buildings. So these these important things. So if you have already worked with any type of a data, so finding such a clean data is absolutely difficult. So yeah, you can use OSM, you can use any other data sources, but I think everything that you will get the update and you will take care of the maintenance is very important. And if you lost just one of these steps, more specifically, process of the updating of a data, if you start sending not correct data, your model will be messed up. And yeah, okay. So let's take a look at this data together. And also according to our data set of our applications, how good is that? Yeah. So here we can see that, okay, the WHS is Wohnen in German, and it means that the building is a residential building. And TGR is Tiefgarage, so it is underground garage. So in that case, yeah, there's also definitely underground garage. It shouldn't be heated, but the Wohnen or the residential one should be heated. So definitely it's important for training our application. So I think you have already understand what are the most important thing, and also according to the uniqueness of the data, because we wanted to show you that how right now dynamically all the data is passing from the 2D to 3D. So we have a concept of the GML ID. So this GML ID, which is the unique identifier of the each geometry. So it is the same in both in LOT2 data. I will show you right now. Okay, so I will switch again. Oh, I have already closed it. So let me open again. Okay, so I will just go to the data, CityGML data. So again, you have already seen one zip file. So it already exists. You don't need to download anything or do hard work of going to the GeoPortal and search for anything. So again, we have here the most easiest way, just open it in one. So I will do CMD. And after that, if you install VS Code, so you can open it. So it doesn't matter VS Code, PyCharm, you can open it anywhere that you want. So again, I wanted to back to the data structure. So you need always the connection things. And also your AI model should understand even plus all the geometry things and these things, the unique identifier that it should be increase the security of your model. And so let's try. I have already heard a lot about working with the CityGML data, updating them. So I will talk later about it, the importance of the 3D tiles and so on. But the most important thing here is our GML ID. I think we can find it like this. So let's take a look for one building. So this is again the same GML ID that you have already seen in the ALKIS data. So D is Deutschland, so it is a Germany, and BW means Baden-Württemberg, and also the rest is the unique ID of the data. So this is the point that I told you the source of the data is absolutely important. And because all the source of our CityGML data and ALKIS data from one place, so you can see it easily. Also, I can also import it again inside the QGIS dynamically. Also, this is not a good way to do that, but also the TUM, so University of Munich, also they have a tool just for processing the database, and I think TU Delft also they have a very good tool for that. So where I add the data? It's there. Yeah, exactly. So here you can see, so all the CityGML data, if I just explain it a little bit, not more. So we have a roof type, surface types, and ground surface, roof surface, and wall surface. Let's also take a look at it here. So roof surface. So as you see, this is a roof surface, and then we have a wall surface, and also we have ground surface. So again, as I told you, it is important. So in Germany, so we have, so when they are making these CityGML things, always the footprint is the ALKIS data. So we are 100% sure, not 100%, so almost sure that if we have any CityGML data, they have the connection with our ALKIS data. So then we don't have any fear of these connections of the data. Then you can see this is our data set, and so with this GML ID, we will connect both ALKIS data and CityGML data. So we will talk about these things later. So another important thing, so before working with this application, so let's open this one, is API. So the first thing, even if you have already trained a model, it's absolutely a wrong way if you are not connecting to the API. So if you have a data, if your data is not connected to the APIs, again, it doesn't work at all because you need a real-time interactions between the users and also your data. Your model also should get the latest update. And if your data doesn't have some levels of priority, I mean that, so for example, if you don't know what type of information users are passing, and also according to the security, if you are not giving a different type of security levels, so to your input of your AI models, training it and keep it up to date, it will be absolutely difficult. So APIs are really, really important for training of your model. I mean, for gathering the data and also for providing the information to the users. So let's go to a little bit more practical things. Okay. So I will just open. So here you already have this link. So backend jswordtech.com geospatial. In this link, so you have your endpoints. So this is our endpoints to our APIs. So for those who don't know what is API, API is a language and communications between different type of softwares. You have a mobile application, you have a desktop application, you have QGIS, you have ArcGIS, any type of geospatial applications. With APIs, you can add all the security things to your input and output data. You can do these end-to-end encryptions and all those things. And you will be 100% sure that no one, not 100%, you will be sure that your data is securely transferred between the users and non-users. Okay, I will go to the community. And also here you can easily use guest and guest 2025, 2025. If you are interested, feel free to log into GIS World website. So then after that, you can access to whole APIs. So GIS World is the uniqueness for everyone. So we wanted to try a lot to make these 3D applications available for everyone and more specifically for the students. So they should have a good understanding of the geo and AI. So this is the aim of the GIS World website. So just let's find a community ID. So maybe I can also open the, so we don't need these things. So backend, so GIS World. So here API docs. So this is the best place right now to see all our open access APIs. So here we have our geospatial community, and then with access to the community ID, you can access to all the buildings geometry. So I did the same thing in the search bar, just I search Bissingen. So now I have the accessibility to the community ID. So I will just take it and hit it. And then after that, I said, I need just the buildings. So as soon as I'm hitting this endpoint, so I will have access to whole clean data set. I will be able to give a permission to users, upload the data, update the data, put, patch, or delete, or whatever, according to ourselves. Here is modified GML ID. So I will show you later how Cesium is handling the CityGML data. So how we can connect these two things dynamically on the fly with the Cesium 3D tiles. So then we have such an information, you can pass it to the front end and so on. Okay, so this is our data set right now. So let's give it a practical things inside the QGIS. How you wanted to work inside the QGIS with the APIs, forget about geo-package things and all those stuffs or PostgreSQL or so on. So, okay, so QGIS, so I think most anyone right now who has already at least hear about GIS, so I think they should be familiar with QGIS. Just you need it, and here we have a button. So it's about Python console. So when you are clicking on Python console, you have this also in the GIS Word. So we have also such a tutorials. You can also, if you wanted, you can also follow them. So then let me also close these stuffs. So with this button, you can access to different directories and different scripts. So again, if I maybe I can switch to so in our GitHub repository, so we have a one folder which is called PyQGIS. So inside the PyQGIS, we have some very, very, very simple codes. It is not that much fancy things. It is just for one community. So I just wanted to, so we wanted just to import them right now dynamically in QGIS and a little bit work and how such a things are working in QGIS. So then PyQGIS fetch buildings. So these are not very high level code with object-oriented functional, just very easy things to get the first understanding of using the API in other applications. So maybe I can explain it a little bit. So I should maybe here. So I'm using PyCharm. You can use anything that you want, Visual Studio Code or anything else. So in the PyQGIS, so I have this code. Just I will explain it. I don't want to do any coding right now on the fly. So this is a very simple, very simple code. Here is the information. Definitely, it's not a good idea to hard code of these things, but yeah, this is just for the speeding of the workshop and so on. So you can use it also, or if you are interested, you can log into the website and create your own account and access to all the APIs. So here we have this endpoint API token. So and after that you will get your access and refresh token. So with that one, whenever you are sending a request, and so web server will analyze, okay, this is the accepted or not accepted user and so on. Then here we are just, this is nothing, just it's checking that what you are doing. And then after that here, so all the data, so because we are using it for our web applications, and for the web applications, always we are using WGS. So also we can use UTM, but it has their own challenges. But in general, in this scale of applications, we are going from the Baden-Württemberg to the Sachsen. So we are changing uh, so from one UTM to another one. So in that case, we need, so WGS has a better performance. So it's very easy. Just we are making one temporary layers. So these are the items. It's not very clean. So you can have definitely in the best practice. So you should have a Postgres table with all the names of your columns and so on, and then import it and connect it to the to here. So it's very easy according to our so columns. We are just making a simple layer, yeah. But it is so it is temporary one. So just this. After that, we are going through all the things, and then dynamically we are converting the UTM to the coordinate system to the sorry, from WGS to UTM. Okay. And then after that, it's very easy. We are just adding it to the QGIS. Not very difficult. And so just this. So let's import it to the QGIS and see how is the performance of that. So easy, just import it here and just hit the run to see how much time does it takes and so on. Yeah, it's absolutely fine. So with this approach, you are providing your customers, you are providing the end users, even non-GIS users or those people who doesn't have a good understanding of a GIS, a correct and understandable data. You can see that this is exactly same that the data that I have already shown you directly from the PostgreSQL. But the good thing, you will be 100% sure no one can touch it. Yeah? And then everything, it's not editable because they don't have the permission of the editing of that according to the API things. So also maybe we can just change the community ID. So good. So then, so another municipal, so we have, because of again, these data security things, so we have already activated just some of them. Municipalities were also this, so Mulhausen, I think it should be correct. So let's take, yeah, Mulhausen. So this is also when you are opening the GIS World website, this is also the same municipality with this Gemeinde ID. So where is that? So I will take just the Gemeinde ID of that. So let's give it a try. I think in part-time it will be a bit faster. So where is our community? I will just duplicate it, comment it. Good. Then after that, so also the code is updated. So I will run it again. So this is a bigger community compared with another one. So it has 3 districts. So let's see. Also, the speed is fine. And also we have already received the data. So the next part of the code that I wanted to tell you right now, it is regarding so our GeoAI app, which is running right now on the server. So we should pass the geometries. So we should pass the geometries, please, plus all the energy informations. So we will pass them to the GeoAI via a post request, and then AI will pass us the main pipes and house connecting pipes. So maybe we can go to the next code. So you just fetch main pipe and house connecting pipes. So with this approach, maybe I can just run it. So we will send the request. So I think it was this one. So maybe I can just remove these. So maybe I don't know, maybe we can give it a try for this area. So maybe I can first of all explain the code and then we can just write it. Again, it is all of them are same. So here we have our credentials and those stuffs. And then we have just so selecting the area, and after that, again, the same component. So we should send a data, we should send one post request to the backend. So also then we should again convert it to the from WGS to UTM, then database, because it has the database is trained by not sorry database, and our AI model is trained by the UTM system. So it should be accepted as a UTM. So we are converted again to the UTM from WGS to UTM. And then here it's about loading our data. So which type of information we are getting about the heat density, length of the pipes, building ID, and so on. So here it's our, so the console part, and also here we have a server response. So I will show you, and also here is our payload. So we need to send the backend, a type of the polygon, and also a list of the coordinates. So this is not that difficult, and this is some fancy codes. Okay. So then now I will switch to the QGIS. Again, the same approach, just we should import the file and just, let me just, at the first, we will just run it to make one layer. So for example, this selected area. So just I wanted to need a polygon. So also I can type purely right now, what are the coordinates, and sending to the back and get the response. So then I will just, very simple. So now this is the area. So this is the area. I will send it to the back. So as soon as, so this is, it will take a bounding box of this area. And then in this bounding box is a start doing, so first of all, the main pipe. And so for training that I have already explained it. So for the main pipes, we are using the OpenStreet data, and also for the buildings and for the volumes and all those stuffs in the back, we are using the CityGML plus ALKIS data. Okay, so when you draw it, just again, you should run it. So we are sending the data to back. Oh, it's good. It was fast enough. So before checking the data, just let's check the responses. Again, so this is the same thing that I have already told you. So we are sending the same request. So maybe also I can do it in another way. So also you can have a good understanding. So what we are doing. So I think for Bissingen, so this is a Bissingen. Let's go to the API documentation. It has been mentioned that so community ID buildings plus select connections. So community ID buildings and select connections. Let's see. So we have already hit this endpoint. This is exactly the same thing we did inside the QGIS. So then we have this raw data. Yeah, the documentation is not that good, but so I should correct it later. So just I will send exactly the same request from Django REST framework, copy. So I will paste it. I will send a post request. I think that's also I'm really satisfied from also the respond of our model. So here you can see all the house connecting pipes. And the good thing is, as I have explained it later, the data is very important how you are training the model. So you can also see that how we will check it right now, how it was the quality. So you can see how perfectly also return the building IDs. And also if we go down, so also we have the main pipes. So it has a two objects. One of them is house connecting pipes and main pipes, and then you can import it to your any of the applications. So let's see right now, then maybe we can check the results. So this model is trained, I think, some month ago before Intergeo. So maybe, so here it looks absolutely fine. Also here also good. So let's see if we have any buggy things. Yeah, it looks good. It looks good. So if I can find any problems. So the one of the challenges, so it's good. So as you see, so it has already been predicted. Good. So the streets. So if I wanted also to back as an OpenStreetMap, so we can also see how it works here. So you can see that almost it's predicted good from the OpenStreetMap, and also it has a good connections to the building. So maybe we can also try it one more time. So send another request. So then, so let me just open again. Then, so first of all, we should run it. So this is just a sample things. So you can use it in any other application. So maybe I don't know where can I use it, or maybe this part. But the first step is definitely your data should have the energy demand and energy consumption. Otherwise, it cannot estimate the heat density. So again, we will make one polygon. We will run it again. So we get the new pipes. So maybe here we can find some problems. Also here, that's fine. So two buildings in one land parcel. So how to connecting pipes are accepted, because there are some rules that if you have a land parcel, so the pipe, it shouldn't through from another parcel to the house. And the aim of the heat density is, so we wanted to completely bring out all the heating system from the buildings and put it somewhere. So for example, here. Yeah, it's absolutely fine. The response is absolutely fine. So in that case, if you have your APIs, so it doesn't matter where is your application, you can give it access to the users and then they can use it. Also, we have a one plugin, but unfortunately we couldn't able to finish it till now, but as soon as it's also finished, so we can also publish it. So you will have access to that also openly in the QGIS. So you can access to all these stuffs. Yeah, it's good. So then maybe I can right now switch to the most important part, the 3D web applications and 3D visualization, 3D ties, and all those topics. So I think I don't need any more QGIS, so I will just close it. So all the extra stuffs. Okay. The next part of our tutorial is, and also our workshop is, I made a very, very simple application. So you don't need, so it's with a Cesium and plus again, our APIs. So So this is a very simple format. So in the final format, you should just clone it and run it, and it is connected to also my Cesium access token. There is no problem. So you can also use it. But this is the better approach. You have your own. I will explain you how you can get it right now. So you see very simple HTML, CSS things. So there is no React or any other so fancy things. And I will explain you all. So, okay, so let's jump into the Cesium. So I think most of you, if you have already heard about the 3D, I think you have already become familiar with the Cesium. Cesium is the US-based company, so and also they are really pioneer in such a 3D things, and so they are I think they are one of the best. So you can easily make your account here. I think you have already did it. So I will just log into the Cesium IN. So they are two parts, CesiumJS and Cesium IN. So Cesium IN is not free and it is not open source. So if you wanted to do it for your study, for your PhD, for your master, or if you wanted to do just some testing projects, it's completely okay. But if you wanted to do some commercial things, definitely you should buy, and it is not that expensive. It's about monthly $150, I think, and it is just for hosting a data, and it works. I will tell you. So this is the Cesium IN user so interface. It is very easy. You can make all these story things, all these fancy things. But for me, the most important thing is the 3D tiles. So handling a large amount of CityGML data. So for Baden-Württemberg, so it will about 400 to 500 gigabytes of the data. So handling all these data, it's absolutely difficult. And training your models for calculating the volumes, area of the walls, and so on, it's crazy. But we can, so it is not that approach if your application is that big that you are able to pay 150. So I think it works. So the first thing is very easy, is about these asset things. So maybe we can do something right now together. So just click on it and add your files. So you can do two parts. You can directly upload your GML, CityGML, XML, any format, GML or XML files, or the best approach always do it with the zip file. So you have right now 10 gigabytes of the, so when you are doing it with the zip file, so if your file is 200 megabytes, when you make it zip and it is 9 megabytes, you are using just 9 megabytes of your storage, not 250 megabytes. So zip files always is a good approach, but take care that don't add too much information. Also, Cesium is absolutely perfect in the tiling of a data and making a 3D tiles and streaming a data, but it is your application. You should also know that how you are handling this huge amount of data set. And if it is connected to any GeoAI app, it will be much more worse there. Okay, just you should click on it, and also here we have this new approach. I think 3 years ago, 4 years ago, when I started with the Cesium, so it was a very huge work to clamp all the data to the train. So here it is a Cesium train. So this is not that accurate, more specifically when you have a different type of elevations. So if you have the digital train model, you can use it, but also you should always think about the optimizations of your application. So you want to make your application fast and optimized, or you wanted to make your application very accurate. So it depends on the scale of your application. So you can use both. Just import the data.
Uh, Mohammed, sorry for interrupting you.
Yes.
I want to ask, so what people have to do now is to go to this URL that is written here,
Yeah.
correct? Cesium.com, which is a bit small because it's difficult for people to read it.
Yes. Just they should
So,
just in the
oh,
Google just write Cesium.
Okay, they write
Then
seasonal is just because I know that there are some people who are trying to catch up with what you are doing.
yes,
Okay, CesiumJS,
exactly,
and they
CesiumJS.
found that they themselves here.
Exactly. Let me
Okay,
just exactly. So as soon as you are searching a cesium on Google, when you are Googling it, so you right
yeah.
now you have the access. So I think so it is very easy. Just they should make an account. But if also they don't have account, it doesn't matter because I have already attached all the tokens from our site, so they can use our tokens. But just if they wanted to do it by themselves, first of all, they should make an account, and after that, they can do all these stuffs.
Okay. And so now you can go back again to the web page where you were before.
Yes, okay,
Good.
okay.
Thank you. Thank
You're
you.
welcome, you're welcome. So yes, and then it's back. Or maybe I can just do the upload one more time. So just you should go to just your assets. So assets is the area that you can host all of your 3D and CityGML, your 3D stuffs. So then you should just click on add files. And after that, you have this zip file. So I have already added for you in this GitHub repository. So then also you can add 500 megabytes of the data, but it will take a half a day to be uploaded to Cesium. Again, here we have the two options. So Cesium train model is absolutely fine, and also the performance is perfect. So I can say these things. So when you are putting your data there, so definitely your, for example, all the DCTGML data has already been made with the point clouds. So they are very accurate. So maybe the error may be some centimeters. So, but the Cesium word train, so maybe you will have everything is flying. So with this approach, just Cesium, what Cesium is doing, just make a differences between the height of your data and what is the level of the Cesium, just they will match it, or it is clamping data to the train. Then after that, just you need, so if you don't do that, your data will be fly. So when you are importing to the Cesium. So then just upload, and then in couple of minutes, so your data will be ready in the Cesium. So you can access to the 3D tiles without making any special effort. So if you have already experience with creating, so making the 3D tiles from the FME, ArcGIS, yeah, it's really difficult. And after that, you should connect it, and then you should put all the pressure on your server and also on your local machine to stream all these heavy data. But here we will push it everything to the Cesium, and Cesium will do all those difficult stuffs. Then also you can access to different type of things. For example, I have already added different type of objects. So you can add different 3D object models. So then, so if you have a model, for example, in our applications, for example, the connection between the pipes. So we have a valve. So if we wanted to visualize it, we will put just a 3D valve object here in the Cesium, and we will just put it on top of that point that our AI model is generating. Then I have already told you about NRW. So NRW state, they have a huge amount of data sets about huge amount of point clouds. So I have already streamed some of them. So what I mean by clamping is this. You see that right now, some of the point clouds right now are flying, but you can also fix all those things manually. So if I just come out, okay. And yes, these are a lot of options, and just you should just adjust tile set locations, and then you can just change the height. So for our application, for example, for the Bissingen, this is the data. I have already put it there. So here we have our asset ID. So this is a very important thing, this asset ID, because with this asset ID, you can access to this stream of the data. Okay, so first of all, this one, and so I will open maybe the start code. So here we have, again, let's just, I open it. So if I'm back, so this is our folder directory. So inside the folder directory, we have one start and final. So final is the ready code, and they are same. So this is completely the ready code, but the start, I have already removed the tokens and also the asset IDs. So maybe you can just understanding how the data is coming to your front end. So just please open this file in this directory, open it in any text editor. So you can do it in Visual Studio Code or you can do it in PyCharm, anything that you want. So I have PyCharm. I'm doing everything front and back end all in PyCharm. So you can, but it's up to you, and you can do it in any other application. So let's see, where am I? Okay, so here is the root of my codes. This is not absolutely not difficult things. We have very simple, but one index.js and we have just one index.html, not more. So we don't have any React or Angular or any other things. This is a very, very, very simple HTML stuff. So maybe, so I can open the final one. Maybe we can just run it one time. So, but I will back again to the start things. So the first thing, so let me also delete my node things. So all the libraries. A little bit time. So I think, yeah, now it should be deleted. Good. So when you are cloning, so you don't have any node module, you don't have any list or any such stuffs. So just the things that it's important in your terminal, also you can do it in Visual Studio Code. So the only thing is I need node version. So as soon as you have this node version, so you will be sure that everything is done according to these applications. So you have already installed it. Otherwise, again, please back to our Git repository. So here is the link to that. You can just download it. That it's very easy. If you are on Mac or Linux, it's very easy. But if you are also on Windows, also it is just a couple of clicks and then you have it on your system. So then when you have this node module, just open the package.js, then let's see where is our stuffs. So in that case with the build, so you can build the application and it will be ready for the production, and also with npm start, so you can just it is like a development tools in run dev in React. So but before everything, just we should install the libraries. So all the libraries, so they are here. So npm install or npm I, or also if you are using these JetBrains products, so it will be also bring run npm install these stuffs. It takes some minutes, so all the libraries will be installed. Good. So now everything is so good. So now I'm in this directory, root directory. Just you should write npm start. So then the application, you can just see what will be the end of the application. Then we will back again from the start and we will talk about it, how those stops and connections between the APIs are working. I don't like really Windows, but yeah, it doesn't matter. Okay. So this is, again, that application that Hamid has already explained it to you. That one on the server is the React base. So, but this one is the very simple one, just for you to get to know how Cesium is working, how the APIs are working, how all those connections. So think it's because of the Zoom, it's a little bit slow. And also I'm using these CDN things and stuffs. So also I don't have a direct installation. So we can also always just right click somewhere and open your inspector. Sorry for me, it's in German. So then you can also see how your APIs are working. So everything is localized. I think now I'm getting, yeah, all the data and information correct. Okay, good. So we should wait until all the data is loaded. Also, this is because of connecting to the Zoom, and my computer is not bad, but oh, okay, I have also some warnings here. Okay, so now, so this is the end of the applications. So if I wanted just to split it this side and this side, so I can explain it much more better. So where is the Bissingen? So these are all the pure data that you are seeing. So in Cesium, so I have all the data there. So in that case, you are hosting all the heavy CityGML stuffs. So you can store all of them on your own server. You can do it on your database system, but you cannot have the same performance like a Cesium. So you will put all the pure data there. Then with the GML IDs, just you are connecting the informations. So then, so if I click on this building, so you have this pop up. So what is this one? This is that GML ID that I have already showed you beginning of the tutorial. So the GML ID, which is everything based on OGC standard, it is coming from the ALKIS data and from the CityGML data. So 2D and 3D are connected with this ID. So now, so also maybe I can just run it inside the Cesium also this code. Also, maybe we can see that pops up inside the Cesium. Sorry. So here you can see right now, these are the pure 3D tiles. So there is nothing. So if you are clicking on each building, so which type of information you will see, these are all the informations which are in our CityGML data. So maybe I can again jump into the CityGML data to explain you how these data are coming. So data, CityGML. Just I wanted to show you how these stuffs are working. So one of the ideas that everyone is really interested to direct update of the CityGML data, that I am a person that I don't like to do it at all. So you can see these GML ID or these information 2000, 3000. It's about the information of the roof, and these are the data of the capturing of that data. And I think also we have some address things. So if you wanted to add any data, so for example, now you have already calculated the CO₂ value. So if I'm switching to these two things, so if you are right now clicking on any building, so these data, it's coming from the API. So it means that these data are hosted on your own server. So if you have any data security issues, don't think about it. If you have any fear that you should put your data on a Cesium server, again, with this approach, you have no fear of that. So in that case, just the end user will see the result. But as soon as you are just trying to update CityGML data. Just think about you have already add CO₂ emission value directly inside the XML file. So it means that everything is inside your data. Any type user wanted to update anything, it should update the CityGML data. Then the whole process should be repeated. So updating CityGML data, and after that, making the 3D tiles and then pushing into your front end. Then a lot of people will say that, okay, when we are making the CityGML, we can directly import it to the web application. But again, you cannot get the same performance of the Cesium at all for the rendering the tiles, even if you have the best servers. But yeah, this is the approach. I think you have already understand what is the main of the API things. So right now, instead of visualizing such information that coming from the CityGML data, so also there is no problem to become public because the data is open. And also it doesn't matter to be stored in any other servers like a Cesium in any other countries. No problem because totally it's open data. And so then maybe we can also try one time here. Then so again, this is the same approach. So when you are drawing any polygon here, it is the same thing we did in the QGIS. So you are just making a polygon somewhere, and also you can do it in 2D, so it doesn't make sense. So then with one right click, so you will send the data to the back. Let's see if we can right now get the response. So I told you it is pure HTML, CSS. So please don't expect beautiful UI things. So you can see very beautiful things from the Cesium, and it is much more understandable for other people than QGIS, definitely. So if you're okay, I found one beautiful problem from our system. So also I can right now explain you why the usage of the buildings are important at that time at the beginning. So here we have the residential building. So the residential building is heated. So here if we have two other buildings, so garage or I don't know, something else which are not heated. So you can see these are not gray, but you can see the pipe is directly go through the garage. So we have already trained our model that if such a things happens, so the pipe should come from this part and connected to the house. And so this is the problem that I've already explained, that your data and how to clean the data and how the process of the data, it's that important. Okay, so these are the general approaches, and you have already understand what are the 3D tiles and how Cesium is doing all these great things, and also how how we can add the data in the Cesium IN and how we can right now bring it to our applications. Okay, let's back again to the Cesium IN. So, and also now I wanted to kill this one. And now I will go to the start. So this is the start part. So if you are on PyCharm or any other things, definitely you will have a tool to see some to-do lists. Also, if you couldn't find it in our coding system, so just go to the JS folder and just click on Cesium config. So in the Cesium config, I have already add two parts. One of them is this access token. So that you should be take care of this access token a lot, because as soon as you are giving the access token, so Cesium starts handling these streaming things. So if someone take your token, so they can just do the streaming, and so you have some limitations for getting all these stuffs from the Cesium, for example, these Google photorealistic things or such a application. So they start using it, and after maybe you will see after 8 days, so your account and all these streaming things are done. So this access token is important. So I will tell you right now how to get it. And this is the asset ID that we have already tagged. So Then please go to your CesiumIN account again. So here we have access token tool. So in the access token, feel free to create a lot of token things. Also, this is very good. So if you are a developer or anyone who are getting the data from any municipality or any commercial things that you don't want it to give it so permission to download the data, because as soon as you are publishing your data as a 3D tiles, so anyone can catch all your data on the fly. So with this tool, so you can define different type of the tokens with different type of permissions. So for example, this is my token. Again, this is full access. So this is for the CesiumJS tutorial. I made it. So in that case, everyone who open that applications, they have all the rights to download it, to get the asset, to read the asset, and those stuffs. So making such a things, again, if you wanted to handle all of them on your local server, this is again another things. So you should handle your APIs and also you should handle the credentials for your geodata. So this is the good thing. Just please take one of them. So maybe I can just take this one. So just copy it, or you can also click on this button to copy it, and then just back to the your coding environment. So where am I right now? So I am in the final. No, I should be in the start. Okay, good. So then just the only thing you need to copy paste it here. Again, I don't want it to go deep inside. So start coding and those stuffs, just the general things that give you the general overview of how the applications are working. So then another important thing is the, sorry, is the asset ID. So asset IDs, so there are 10 different ways of accessing the asset ID if your project become bigger and bigger. But the most easiest way is just, for example, I'm working on the BSingen. So here you have this ID. So this ID is uniquely identifier your 3D tiles for this asset. So just again, you can just copy it and put it in the to the start just here. Oh, drawing. So Disney. Okay. Good. So with this asset ID right now, you have access, sorry, to render all the 3D tiles in your application. So these are the very simple to do things that you should do. This is your access token. Again, if you don't have it, just open the final one and you can check everything from the final version. Then after that, I will back to index.js. So again, this is not that complicated things. So it is very easy. We can just check it one by one. So when you are accessing to the Cesium, so this application also it's with the Webpack. So this is again another way of using the Cesium directly. So you can access to the Cesium via CDN, and also you can use it like this, like a Webpack. So also we have the complete tutorial of that if you want it. Also you can take a look. But right now we are using this Webpack. So we are downloading the whole CesiumJS libraries on our local machine, and then we can access to whole libraries like that. So same thing you are doing with React or such as stuffs. So then just you are passing your access token. So if I just split it to right? So we are just calling it from here. So you have one config file. So also this config file, it shouldn't be go to the GitHub. So right now it's in the Git repository, but it is just for the tutorial. So all this, so it is very beneficial not to put such stuffs in the Git repository. So this is, in that case, definitely we should add it in our git ignore file. So we shouldn't pass it to the GitHub, such informations. So this is the same stuff uh, for getting the token. Uh, And then, so just we are checking if it is not correct. So we are just informing users, not more. Then another point in the viewer. So what is the viewer? If you wanted to access to any type of these stuffs, so you have, this is the Cesium viewer. So all these stuffs you are seeing here in the Cesium, it's a viewer things. So in that case, just we are saying that we are using this viewer and we are passing the Cesium train to the viewer. So in that case, those clamping things that you see, it's happening in this background. Sorry. Then after that, we have our tile set. So anything that you are uploading to the Cesium, so it will be as a tile. So it doesn't matter, it's a GLTF format. It doesn't matter it's the CityGML data or point cloud data. So Cesium is looking everything as a 3D tiles and the tile sets. So in that case, for example, if you have some even beam data, so I can also show, I think I have one sample of the beam. So this is also beam data that is directly imported from the Revit to the Cesium. So if it opens, so this is our Revit stuff. Okay, and this is a beam data that it's exported directly from the Revit to the Cesium IN. Then it makes a 3D tile. Then right now you can import your 3D tile inside your application. So again, so this is the stuff. And with this one, you are just adding your 3D tiles to the viewer, to the scene. And then it will be automatically zoomed to that area. So these are the first setting of the Cesium. The most important part for me and the most interesting part, it's here. So it's like, where is it? Okay, sorry. So right now we are sending one again request to this backend. So as soon as we are sending a request to backend, all those stuffs we see in the QGIS, it will appear in the front end. So we have the GML ID of each building. So let's again back to the Bissingen. I think I should do it in other way. I should open it in the, so if it's loaded. So in our API, we have our GML ID and also the GML ID. So we have one modified GML ID. And also we have the same information. So inside each building. So in that case, I have this modified GML ID. So in this case, so the easiest way. So if I just go to one building, so GIS Word, geospatial, then we have our community. So then buildings. So in this case, also you see that we have one modified GML ID and we have one GML ID. With these two approach on the front end side, we are just dynamically connected our API information to the Cesium 3D tiles. Then let's check buildings colors. So right now in this one, we have the tile set information and also we have the API information. So in this case here, it's very easy. We are just updating the style of the Cesium. So just, it is a very simple thing. You can easily find it in the Cesium to CesiumJS tutorials. So GML ID, so from modified GML ID. So this modified GML ID is coming from the API. Easy. So in that case, you know that what is the information on your own server, then pass it that information on the fly to the Cesium 3D tiles. Then after that, also if so that expression or that query is not correct or it's not passed, so the color will be white or gray, dark gray. Then after that, you have the complete style for the complete tile set of the buildings. And after that, just you will pass it to the viewer, and then the whole information will be updated. So the same approach we should implement for the pipelines. So in this case, you will just, so this is your root. So backend, jsword.com, geospatial community, then buildings, then select connections. So again, you will draw something. You will draw a geometry. So it doesn't matter right now. It should be in Cesium or it should be in Leaflet or any other web tools. Then you will
Muhammad,
choose.
I give you few minutes because we have some questions and we have to close in 15 minutes.
Yeah, I'm done right now. Just 2 minutes, and
Okay.
then yes, I will
Okay.
finish.
Very
Exactly.
good.
Yeah,
Thank
yeah,
you.
yes. You're welcome. Yeah, exactly. Then just we are getting the API and just passing it. So then the same approach, you see that we have a polygon. So we have a polygon type coordinate. This is the input of the API. And then after that, we have again the header things, the same thing we had in the QGIS. Then the same information. So clear the pipes. So if we have a new input, and also then attaching the pipes to our model. So this is the whole thing. Then you have also access to all those stuffs. So this is not that complicated things. And also this is the drawing tools. Also, this is a very, very interesting things right now in the Cesium. So you can also draw all those 3D stuffs also in the Cesium. So, and also please use always the latest version of CesiumJS, and because we have a lot of new things there. Yeah, just this. And again, also the Git repository, it's public for everyone. And again, if you have any questions or anything else, you can also always contact us. And also as a task, if anyone is interested, maybe you can just implement just this part. So maybe you can just implement the pop-up. So if I just So if I just do the login things. So if anyone just interested, maybe you can do this pop-up stuffs, because all the so as soon as you are making an account, so you can access to the whole data. So maybe you can have this data, just send a one put request and just try and test that if you are able to update any geometry or not. And these Mulhausen and Bissingens municipalities are the best ones. So we have all the informations open for everyone, but everything is the dummy. So again, because of data security and these things, we shouldn't have any problem. Yeah, it was the whole application. So it was very fast. It was a lot of information, but I think it is a very, very good start for anyone who wanted to connect. So first of all, connect the GeoAI to API and visualizing all the information in 3D.
Thank you. Thank you. Thank you, Mohammed.
You're welcome.
And I want to call also Hamid here. First of all, I want to congratulate with you. And I see that there are some questions, specifically questions about the main GeoAI model that you are using. So people want to have more explanation about the GeoAI model because obviously this is a GeoAI workshop and therefore that part was a bit limited. So if you can add something more about that part related to GeoAI.
Yes, sure. So our application is generally the aim of our application. It was the CO₂ calculation. So we have a lot of challenges because CO₂ calculation. So we have a lot different type of parameters. So this application, so for just calculating one CO₂ for one building, we need a volume of the buildings. So right now, with these applications, we have a lot of projects. So at the company, so we have the exact parameters regarding the windows, walls, roof, and all those stuff that Hamid explained. So in detail. So then we had some projects that we didn't get a lot of money from that. Just so in that case, it doesn't make sense to capture all those stuff. So the idea comes to our mind. We have a very detailed information, and also we have this open data of uh, so the Germany, so how we can combine these two. So then, for example, how we use this geodata. So we used from the CityGML data, the volume of the building and all the area of the outer walls, roof, and those stuffs as a main parameter. And then we trained our model based on those detailed data. So right now we just simple parameters, just what is the status of the windows, wall, roofs. Then we have the
But what
CO₂.
is the model specifically? What is the model that you are using? Is a machine learning model, deep
Exactly.
learning model?
No, this is a machine learning model. Yes.
So
So we
it
have
is a random forest.
exactly. Yeah, that's correct. Yeah, it's a random forest. So we had our input data. It was, I think it's about 2,000 to 2,500 buildings. So all those stuffs are calculated with this very accurate the energy softwares. So we get a lot of money for each of the buildings. So in that case, we have a lot of detailed parameters. So then we tried to just some inputs, as you see. So we wanted to simplify it to make it more usable. And this is the first estimations for the urban planners, civil engineers, a smart city, and just the general information for the whole municipality. And then when they wanted to go deep, then they can use these such a energy softwares.
Okay. No, but I want to understand
And
if so you say that you are using random forest
yes.
training on these huge amount of data, but did you also collect some data about the assessment of the model? So, which is the accuracy that you get from your model?
Yes, for these projects, so we have two numbers. So one number is it's coming from these energy softwares that calculate directly the energy demand, and also we have the accurate energy consumption from the users. So first of all, we always compare these two parameters that the number exported from these energy estimation softwares are correct or not. Then after that, we did exactly the same thing. So for just, I think, 100 or 200 of the buildings, so as a test, so that if our model also calculated properly or not. For those buildings, it has a very complex a structure, so if the accuracy will reduce to 70 even or 60% because of the model cannot estimate it properly, the area of the walls, roofs, and such a things. And also, but if the buildings are the normal German buildings with a not very complicated structure, so we can say that even plus 80% we have a good accuracy, but it depends on a lot of parameters, the day of the heating system, the number of the people who are living in the house, and such.
And for the implementation point of view, what are you using as a model? Because I believe you didn't develop the model from scratch. You are using some library, which is connected with what? It's connected with QGIS?
No. Right now, the model is running on our server. So this is not connected to the QGIS.
No,
So
yes, but I mean the you said that you applied the random forest.
mhm.
So it means that you are applying some specific libraries for doing random forest.
Yes. All these SCI, these common libraries that we are using for machine learnings.
Scikit-learn,
Yeah,
Scikit-learn.
exactly, yes.
But this is not used starting from QGIS.
No, no. Just
So QGIS is used only for visualization.
exactly, just for, and also input data. So so we have a lot of non-GIS users that they don't want to think about what is happening in the back. So we are using the web and QGIS just for the user interface, our application.
Okay, and Hamid want to say
Yes,
something, I
exactly.
see.
Just add something. We are just using the QGIS as a bridge between our input data and our database and our model. And because the projects are based on the QGIS file, and after that it will be ready one QField file for the data capturing. As you see also in our GeoAI app, there is also possibility to input the data. But in our company, because we are capturing also images or some videos from building, which is just related for the planning department, and after that this data will be transferred to our database and as an input to our model. And maybe to your last question regarding to our AI model, this is our training data set is not that kind of right now strong, because you see such a parameter like a heating system type from each building is not available easily. And we need to train our model to guess. As Mohammed also said, for those calculation we need over 70 parameters to calculate, and this model reduce it to the 8 with some simulation and some guess and prediction with this model, to reduce it to the 8. And after that, with these 8 parameters, we can have like a 7 is to predict these 70 parameters with the accuracy over 80%.
Okay.
Yes.
So the accuracy that you reach by now is around 80%. This is
80%.
more or less the accuracy that you are reaching. Okay, using random forest. You
Yes.
didn't try to use something else like support vector machine or something, some other models, not by now. No.
Not now, but as I said, this is the somehow we name it as a baby application, because it needs to be developed, and even this training data set, and maybe it is possible to, as you said, to apply other model, to maybe
Yeah.
it is better to increase our accuracy in this way, or even train our data set in the better way. But
Yeah.
it's all ideas, and even your experience would be also helpful for us to develop, because this is a sustainable energy app, which is not only for the for the business aspect. This is for the for our natural life, to reduce
Yeah.
this amount of this CO₂, and have
Yes,
the
yes.
better life at the end.
Definitely. I see. I know that Andrea has also a question about the data. He's curious about the data because we are preparing a challenge where we need to have footprints of buildings and heights of buildings. So, Andrea,
Yeah, thank you very much, Maria. Yes, what I wanted to know, I heard, if I understood well, that your cadastral data is also the information about the building height. So is a 3D,
Yes,
not
you
only the
can.
parcel. Is that
Exactly.
correct?
Yes, you can get
And
the, yes.
and you have this for all Germany?
I think for most of, so we have already tested for entire Baden-Württemberg, it's available, entire Sachsen is available, and North Rhine-Westphalen, so NRW. So NRW has the richest open data.
Okay. And then another point that I want to ask, I went into your open geodata portal, and I saw this data set, this DTM DGM 025, that is a DTM, if I understand well, for all
Yes.
Germany at resolution 0.25 meter per 0.25 meter. I wanted to know if is this open data, is that free?
Yes.
of charge? Because I don't understand German that well, but I sort of understand that there is a cost involved. So I would like to have some more
No,
information.
there is no cost. So all of them are the open data, and as I have already told you, so for example, for entire Baden-Württemberg, you can do one bulk update, and in 2 minutes you can have the whole data of the
Oh,
Baden-Württemberg.
it is really an extremely high resolution DTM at no cost for all Germany.
Exactly.
Impressive.
Yes,
And
it's
maybe I must also add on there, because we are working in the somehow the two main states of the Germany, Baden-Württemberg, which contains over 1,000 municipalities, small municipalities, and also the Sachsen, and we must also share with you those free access just provided a year ago. Previously it was just just the municipalities and the public sector could apply for that, and after that we had this the model to how to transfer this data into the GIS format developed. But recently it came to the open source format. But maybe we should also add this one, and when we are also checking the height of the building, and with some user input regarding to the number of the floors, in some cases is not that kind of trustable. It's getting better, our CityGML data, but we must also say that me and Mohammed see sometimes some inaccurate information from the this open data, CityGML and ALKIS data. And because of that, in our application, our model, all the time we are considering input data as a correct user vision. For example, if they are seeing, for example, the number of the stories or floors of the building, and after that calculating to 3.4, and after that we have the accurate height of the building. In some cases, they are not matched in this way. I must just be
okay.
sharing with you. And about
Okay.
this DTM is also, it is possible to have, it is available, but about the high accuracy, maybe we cannot, say it in the 100%. This is the very high accurate in this way.
Because you mean that the height of the building sometimes is not measured with a LiDAR, for instance, but
No,
is simply measured with the number of floors.
no, because of the dates. So, for example, it's very expensive to make such a thing. For example, for some small
know.
municipality, so maybe it is done in 2016 or 2018. So in that case, maybe in between we have some renovations in that area. So
sure.
maybe, so it's in Germany, it's very difficult to demolish a building. So maybe they just added just some stories on the, for example, to the roof. So in that case, so we have these manual options that they are just adding, okay, right now, instead of one roof story, we have two roof stories. So in that case, in CityGML data, it's one, but in the real world right now, it's two. Or maybe they have some renovation, and so these stuff. And also in Germany, it's possible they are just hitting 60% of the living area, or even so we have a very big house, so the family house, and then just they are hitting just one story. So in that case, we added those options that they can use with the percentage. So we will rebuilding the building, and then we calculating the area. So these are the reasons that we added those parameters.
Yes. No, but for sure, the system that you are building is very ambitious. I have to say, the problem to solve is very complicated because it's true that we have a few data. In any case, I believe that reaching 80% of accuracy is an absolutely good starting point. Please consider that, even if there are other models that you can use, there is not the perfect model computing the perfect word if you don't have data for training it. So that is there is no model doing the magic, and so now it could be that you can improve a bit for instance, with ensemble models, putting together different models, but not reaching 100% if you don't have data available.
That's absolutely
Anyway,
correct.
it's a very good starting point, I believe, and I enjoyed a lot all the part related to visualization, which is also so important to perceive the results of our geospatial analysis. Um, I believe we are out of time now, so we
Yeah.
have to close. But thank you so much. Thank you both, Hamid and Mohammed.
Perfect.
Was very good, very impressive, and I'm pretty sure that our attendees also enjoyed a lot. And with this, I give the word back to Andrea because he has some important messages to convey to the people. Thank you so much. Ciao, Mohammed, and ciao, Hamid.
Thank you
So
very much. I want to thank Amit Rez and Mohammed for this really great event. It was a very didactic workshop, very clear. And thanks again to Maria for having moderated this event. I want to thank also all the participants. We're sure that you learned new skills in this workshop, as we also surely did. I want to inform that the workshop material will also be available from the neural network. And of course, you can watch the recording on YouTube and the neural network. I want also to remind you the next planned event for the GeoAI Discovery. This is another workshop organized by ESA and IBM on geospatial foundation model. Will be on 18 of November on TerraMind, multimodal foundation model for Earth observation tasks. So I will finish by saying to stay in tune for this exciting development in GeoAI and geospatial foundation models. And I thank you again, all of you, for participation. And with this, let me give back the floor to Anna. Thank you very much.
Thank you for participating in today's AI for Good session. We hope you've learnt something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the e-shop, and build your personalized AI for Good program. Let's shape the future of AI for good.